In terms of R, what is the area in purple? Well, we have 4 circles that are inscribed inside of a larger circle. And the area that these circles do not take up is the area shaded in purple. So how can we find this purple area? Well, first, we need to be able to find the radius of this larger circle so that we can find the area of the larger circle. Then, when we have the area of the larger circle, change my tool. When we have the area of the larger circle, we can subtract 4 times the area of the smaller circles because we have 4 smaller circles inside of the large circle. The question is, how do we find the radius of this larger circle? If we can answer that question, we'll be able to solve the problem quite easily. Well, we're going to have to do some creative geometry here. And the first thing that we need to do is approximate the centers of the other 3 circles. Now, these center points are not perfectly aligned, so my drawing may not be to scale, but nevertheless, what we can do, if we say that this is approximately the actual center of all of these circles, we'll notice that this distance to this edge is 1 radius, and extending by the same principle from this radius, or from this edge to this center, is also the distance radius. And this distance right here is also 1 radius, and this distance right here is 1 radius, as is this, as is this, as is this, and as is this. Now, what have we successfully drawn? We've successfully drawn a square with a side length, excuse me, this is not a perfect square, but a side length of 2r, because we have 1 radius here and another radius here. And in order for these 4 center points to be connected, the shape will become a square. How does that help us? Well, if you'll notice, if we take the extension of another radius of this larger circle, the diameter of this large circle is comprised of 1 radius length and another radius length, plus the length of the diagonal of this square of side 2r. So if I can find the hypotenuse of this right triangle, I will then be able to find the diagonal of this square right here, add to it 2 r's, then I'll be able to use that as the diameter of my larger circle, divide it by 2, and then I will have the area of the larger circle. So, how do we find this hypotenuse? We have to remember the Pythagorean theorem, which states that a squared plus b squared equals c squared when we're dealing with right-hand triangles. When we have right-angle triangles, the hypotenuse, c, is equal to the sum of the legs squared. So we need to square 2r and also square 2r, and that will equal our hypotenuse squared. Now this is 4r squared, this is 4r squared, and we arrive at 8, excuse me, not h, 8r squared equals h squared. Now to find h, we simply take the square root of both sides. So we have the square root of 8r squared equals h. Now the r will come out evenly because I have a square here, and the square root will undo that square. But 8, unfortunately, is not a perfect square, but it does contain a perfect square of 4. So let me rewrite this as 2 times 4r squared. And if you recall, 4r squared is the result of 2r squared. So unsquaring this term, out when I bring it outside of the square root, I get 2r root 2 equals the hypotenuse. For those of you that remember, this is the identity for a 45-45 degree right-hand triangle in which the hypotenuse of a 45-45 right triangle is side root 2. And you'll notice that our side is 2r, 2r here. 2r root 2 is the hypotenuse. So this is 2r root 2, and we add to that 2r root 2 plus r for my external radiuses here, and that gives me 2r root 2 plus 2r. Now I can factor out this 2r to get 2r onto root 2 plus 1. Now remember, this is simply my diameter, and the diameter is twice the length of the radius. So to get my radius, I've got my diameter. I need to take the diameter over 2, which is equal to r times root 2 plus 1. Now, in order to finish the problem, we simply use the formula for area of a circle, which is equal to pi r squared. So, the area of my larger circle will be pi, and my radius will be this term right here. I have r root 2 plus 1 squared minus 4 times the area of these smaller ones, which is going to equal pi, and simply just a little r this time for my radius because that's the radius of my smaller circle. Now, the simplification of this expression, well, technically, we've solved the problem. In terms of r, what's the area in purple? It is simply this expression here. However, this expression is not simplified and not very pretty. So definitely a simplified pretty version of this exists. The question is,